All right, after we've added, subtracted, and multiplied complex numbers, it makes sense that the next thing we'll do is divide. When it says to write the quotient, that means the answer to the division, in the form a plus bi, well, we use this as the form for all of our complex numbers. How are we going to do that? You will not have a sense of any real division going on. Instead, you're going to rationalize the denominator, and remember, you're going to use conjugates. I is the square root of -1. So anytime you have a radical in the denominator, you multiply by the conjugate, and you do it on top and on bottom, because anything over itself is equal to 1, unless you deal with 0, and we're not. All right, the numerator, distributive property. 6 times 4 is 24, and 6 times -4i is -24i. That's the numerator. The denominator, these are conjugates. The product of the first, 4 times 4 is 16. The outer product and the inner product will cancel, so we don't even have to look at them. The product of the last, 4i times -4i, is -16i squared. So I didn't do the outers and inners because they were conjugates and I knew they would cancel out. I squared makes that sign change to a plus. That gives me 24 minus 24i all over 16 plus 16 is 32. Now I'm going to reduce that because there's a common factor of 8 in all of the rational pieces. If you divide them all by 8, you'll get 3 minus 3i over, divide that by 8, and it's 4. To make MathLab happy, a plus bi, 3/4 will be a. That's this piece. Minus 3/4 I. And that is how it would like that answer written. In fact, I believe that it might count anything else. It might say something like, your answer's right, but it wouldn't like the format. So we're going to, if we're left with this fractional look, we're going to take this piece as the real, plus or minus this piece as the coefficient of I. All right, let's look at the next one. How do we do quotients with complex numbers? We use conjugates. The conjugate of the denominator is 1 minus I. 1 minus I. The product of the first is FOIL. I'm sorry, the product of the top is FOIL. 5 times 1 is 5. That's the first. The outer, 5 times -1 is -5i. Inner, 7i times 1 is 7i. Product of the last, 7i times -i is -7i squared. Let's go ahead and clean that up before we look at the denominator. We know that I squared is -1, and -1 times 7 makes it +7. Adding the real parts of 5 and 7 is 12. The imaginaries, -5i and +7i, is +2i. All right, so the denominator, this is going to be conjugates. Product of the first, 1 times 1 is 1. Outers, inners cancel. +i times -i is negative, implied 1i squared, because there had been a 1 there and a 1 there. I squared goes away, changing that to plus, so now it's 1 plus 1, which is 2. I can reduce, dividing 2 into both of those. That gives me 6 plus I. I divided there, and then I turned around and divided there. You will always get a real denominator because you're using conjugates. All right, on this one, multiply by the conjugate of the denominator, 7 plus 3i, 7 plus 3i. Product of the first on the numerator, 8 times 7 is 56. Outer, 8 times 3i is 24i. Inner, negative I times 7 is negative 7i. Last, negative I times 3i is negative 3i squared. Let's finish that. We know that I squared is negative 1, so when you multiply that by negative 1, it's gone. We have 56 plus 3 is 59. 24i minus 7i is positive 17i. All right, the denominator. These are conjugates. 7 times 7 is 49. Negative 3i times positive 3i is negative, whoops, I lost my fraction line, is negative 9i squared. So the first was 49, 7 times 7. The last is negative 9i squared. I didn't worry about the outers and inners because they were conjugates. I squared is equal to negative 1, causing that sign to change. That means that my denominator is 58. Now my math lab does not want this. It wants it in a plus bi form. So here's a, 59 over 58. It's a plus 17 over 58 I. Okay, I think we have one more to practice. I think it got easier. We're going to multiply by the conjugate of the denominator, which is 5 minus I. 5 minus I. 6 times 5 is 30. 6 times negative 6 is negative. I'm so sorry. I wrote a 6, and that was supposed to be an I. I couldn't read my own writing. 6 times 5 is 30. 6 times negative I is negative 6I. I'm sorry about the messiness that caused me to get confused on that. The denominator, those are conjugates. 5 times 5 is 25. Outers and inners will cancel. I times negative I is negative, remember, implied 1, I squared. I squared changes the sign. So I have 30 minus 6i over 26, because it's 25 plus the 1. These are all even, so I should be able to divide them by 2. 2 goes into 30 15 times. 2 goes into 26 3 times. There's the I. 2 goes in there 13 times. And now I will break it into the a plus bi. 15 over 13 minus 3 over 13i. There we go. All right, so dividing complex numbers is actually multiplying top and bottom by the conjugate of the denominator. And remember that I squared is equal to negative 1.